Hi, my name is Christopher Meyer, and this is my Lab 1 on charge tapes for Physics 2212. So an introduction. So the purpose of this lab was to determine excess electric charge on a piece of clear tape. In the lab, we explored the physical properties of charge, such as Coulomb's laws, which deal with calculating the electric fields and electric forces of point charges. And we used these physical properties to visualize how charge affects object behavior. Our results came out to be that the tape charge has a charge of negative 1.224 times 10 to the negative 8 coulombs, and therefore it has an excess amount of electrons. So in the lab, what we had to do was create a U-tape by quickly pulling tape strip off of a base tape. As you can see from the first image, we had to ensure that the tape is negatively charged then by rubbing a plastic pen against it and observing an act of repulsion with the tape. We would then repeat steps 1 and 2 for a second charge tape, and then we would lift one tape under the other to notice that one tape, the top tape, would begin to float. We would then record the distance between these tapes. Once we have completed the lab procedure, now we'll create a model to represent two tapes and the forces between them. We noticed that the two tapes would repel each other because they're both negatively charged, and therefore from Coulomb's law we can see that the electric force have equal magnitude. We also notice that the top tape begins to float, and therefore the net force in the y direction is 0 because gravity and the electric force would cancel each other out. Now, for calculations, we'll need to assume to treat these two tapes as point charges, and to assume that the tapes have the same charge. Next, we'll use the tape length to approximate the mass as well as the number of atoms, and assume that air resistance is negligible. After completing the lab, we have gathered some measurements. First, the tape length, the tape width, and the distance we noticed between the tapes. Using these values, we would then calculate the force of gravity, which came out to be negative 2.156 times 10 to the negative 3 newtons, the surface area of the tape, which was 0.0044 meters squared, and the number of atoms on the piece of tape, which was 4.4 times 10 to the 17th atoms. With these measurements, as well as the values we calculated before, we now would calculate the tape charge. We would calculate tape charge by first finding the force of the electric force on by the bottom tape onto the top tape, which came out to be 2.156 times 10 to the negative 3rd newtons in the positive y. We then use Coulomb's law to find the charge of the tape, which is negative 1.224 times 10 to the negative 8 coulombs. We would then find the number of excess electrons using the electron charge and a division between the tape charge and the electron charge, which gave us 7.65 times 10 to the 10th electrons. And then we would find a ratio between the excess electrons to atoms, which became 1 excess electron for every 5.75 times 10 to the 6th atoms. Finally, we used GlowScript to model this lab. On the left, we can see a bunch of constants, such as 1 over 4 pi epsilon naught 0, the tape mass per meter, the distance, the atom length. And on the right, we can see calculations which we use to find, such as the force of gravity, the tape charge, or the number of atoms on the tape. From the GlowScript, we got these results. On the left, you can see the model with the blue sphere being the top tape, the red sphere being the bottom tape, 2 green arrows being the force, the electric force, and the orange arrow being the gravitational force. All the values on the right, you can notice, are the same as the calculated values we got from the lab. Finally, we have reflection questions. What if the electrons had a positive charge and protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? The only change we would see is that the tape charge or sign would flip and be now positive. The magnitudes would still be the same, as well as the action of repelling, because the two charges are still the same. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The reason we can't touch the tapes is because these tapes have excess electrons, and by coming into contact with them, these electrons may leave the tape, and therefore the tape would lose charge. Because normally electrons will leave a negatively charged object for a more neutral or positively charged object, and therefore the tapes might lose their charge. Thank you, and that is all.